The most destructive earthquakes in history have all occurred in subduction zones, where one tectonic plate is being forced beneath another, a process known as subduction. This process can lead to massive earthquakes with devastating consequences, including tsunamis that can affect entire coastlines. Let's look closer at Earth science and seismology. But what triggers these earthquakes, and why are they so much more destructive than others? To understand this, we need to look at the mechanics of subduction zones and how they lead to seismic activity. Subduction zones are found at the boundary between two tectonic plates, where one plate is being pushed beneath another. This can happen at a rate of a few centimeters per year, but the process is not smooth and continuous. Instead, it is punctuated by sudden, catastrophic events, such as earthquakes. The Pacific Ring of Fire is home to many subduction zones, where the Pacific Plate is being pushed beneath other plates. This region is responsible for 90% of the world's largest earthquakes, and it's where we find some of the most active volcanoes on the planet. The combination of earthquakes and volcanoes in this region makes it a unique and fascinating place to study. One of the key factors that determines the severity of an earthquake is the rate at which the plates are moving. In subduction zones, the plate that is being pushed beneath another is known as the overriding plate. The plate that is being subducted is known as the subducting plate. The rate at which these plates move can vary, but it's typically around a few centimeters per year. As the subducting plate sinks deeper into the Earth's mantle, it encounters increasing heat and pressure. This can cause the rocks to deform and eventually break, leading to earthquakes. The overriding plate can also experience stress as it is pushed upwards by the subducting plate. This stress can build up over time, eventually leading to a catastrophic release of energy in the form of an earthquake. The most destructive earthquakes occur when the subducting plate becomes stuck beneath the overriding plate. This can happen when the two plates are not moving smoothly past each other, but instead become locked in place. As the subducting plate continues to move, it builds up stress in the overriding plate. Eventually, this stress becomes too great, and the plates suddenly move, releasing a massive amount of energy in the form of an earthquake. The devastating effects of these earthquakes can be seen in the impact of tsunamis. Tsunamis are massive waves that are triggered by the displacement of a large volume of water, usually as a result of an earthquake. They can travel at speeds of up to 500 miles per hour and reach heights of over 100 feet. The impact of a tsunami can be catastrophic, with waves sweeping away entire cities and coastal communities. In 2011, a magnitude 9.0 earthquake struck off the coast of Japan, triggering a massive tsunami that killed over 15,000 people and caused widespread destruction. The earthquake and tsunami were so powerful that they even affected the rotation of the Earth, shortening the length of a day by 1.8 microseconds. The science behind earthquakes and tsunamis is complex, but it's clear that subduction zones play a critical role in triggering the most destructive earthquakes. By studying these regions, we can gain a better understanding of the mechanisms that lead to seismic activity and the devastating consequences that follow. This knowledge can help us to better prepare for and respond to natural disasters, ultimately saving lives and reducing the impact of these events. In addition to the Pacific Ring of Fire, there are other subduction zones around the world that are capable of producing massive earthquakes. For example, the Sunda megathrust in Indonesia is a subduction zone that has produced several large earthquakes in recent years, including a magnitude 9.1 earthquake in 2004 that triggered a tsunami that affected several countries in Southeast Asia. The Cascadia subduction zone in the Pacific Northwest region of North America is another example of a subduction zone that is capable of producing large earthquakes. This zone has produced several large earthquakes in the past, including a magnitude 9.0 earthquake in 1700 that triggered a tsunami that affected the coast of Oregon and Washington. The process of subduction is not only responsible for earthquakes, but also for the creation of mountain ranges and volcanoes. As the subducting plate sinks deeper into the Earth's mantle, it encounters increasing heat and pressure, causing the rocks to melt and form magma. This magma can then rise to the surface, producing volcanic eruptions and creating new landforms. The study of subduction zones is an active area of research, with scientists using a variety of techniques to study these regions. These techniques include seismic monitoring, which involves using seismographs to detect and measure earthquakes, and geodetic monitoring, which involves using GPS and other techniques to measure the movement of the Earth's surface. By combining these techniques with laboratory experiments and computer simulations, scientists can gain a better understanding of the complex processes that occur in subduction zones and how they lead to seismic activity. The impact of earthquakes and tsunamis can be devastating, but by studying these events and the mechanisms that trigger them, we can reduce the risk of damage and loss of life. This can be done through a combination of education, preparedness, and mitigation. For example, building codes can be established to ensure that buildings are designed and constructed to withstand earthquakes, and early warning systems can be put in place to alert people of an impending tsunami. By working together, we can reduce the impact of these natural disasters and create safer and more resilient communities. In conclusion, the most destructive earthquakes in history have all occurred in subduction zones, where one tectonic plate is being forced beneath another. The mechanics of subduction zones and the processes that occur in these regions are complex, but by studying them, we can gain a better understanding of the mechanisms that lead to seismic activity and the devastating consequences that follow. This knowledge can help us to better prepare for and respond to natural disasters, ultimately saving lives and reducing the impact of these events. By continuing to study subduction zones and the processes that occur in these regions, we can gain a better understanding of the complex and dynamic Earth that we live on, and reduce the risk of damage and loss of life from earthquakes and tsunamis.